using deep learning, and so this was simulations, and we even wrote some Medium blog about that. So if you're interested, you can go and read. And so it was a lot of classification things like churn, classical churn use case and stuff like that. So where you try to classify the customers who are about to leave and contact those who maximize the probability to leave before they do, and so a lot of scikit-learn, a lot of Spark, a lot of TensorFlow, a lot of modeling, and again, a lot of love here and a bit more of money. So there was love, there was a decent money. So what could possibly be wrong? So that's a philosophical question, right? The wrong thing is that it was actually difficult, and it is difficult to push these things into prod. And production is, only production brings value, right? So you can build the nicest models, but if they're not in production, customers don't see that, and it's not meaningful, right? So that's why I started to think a little bit more about DevOps and MLOps, how to productionalize these things, especially because of the increasing frustration I got when, we were data scientists modeling and trying to give our models to engineers, whatever that engineer's name mean, and they didn't understand perhaps how to deploy, and there was silo approach where, on the one hand data scientists, on the other hand engineers, and so difficult to push stuff to production. So I went to more productionalized aspects, and there is this picture is very famous. It's on top of the DevOps. It's plugged the machine learning aspect, right? So as Isaac Newton once said, the famous English physicist, we stand on the shoulders of giants, right? He said that about science. So current science is on the shoulders of previous science, and the same for MLOps. We stand on the shoulders of DevOps, right? We benefit from the wisdom of software engineering of DevOps, which is this set of practices and tools and people, this philosophy that allows to deploy software in increments, in fast increments, right? You try to push any increments of functionality of your software to production as soon as possible, in contrast to a more waterfall approach where you build a monster and you try to deploy that in one shot. And in MLOps, that's the same thing. We try to benefit from this approach and add the machine learning aspect of that. So obviously the data and the model, whatever that might mean. And this morning there was a really cool talks about that. Carolina and Ivan mentioned about this what is a model, right? So the menu for the talk is speaking about the challenge. What are the challenges that we can meet? Then talk about what can constitute a mature setup, and try to flesh out such a mature setup using a platform, Databricks. I choose this one because that's the one I've been mostly using during my career. I'm not working at Databricks, so it's not an advertisement. It's just the platform I've been using. And we will, if we have time, we'll deep dive into one aspect of the challenges. So which is the CI/CD for machine learning. Yeah, and so there was 2 years ago this blog from Google, quite famous, I should say, giving a few levels of maturity for the deployment of machine learning models. And I took this picture from them because I think it's a really frequent case that we have. At least I met such case quite some time quite a few times. And this is level 0 of maturity. They have 3 levels, 0, 1, 2. So that's what they coin as level 0. And that's the classical case where you try to, let's say you have a use case classification use case, and you train your model onto some historical data offline, and do some EDA, some exploratory data analysis, then your feature engineering, then you test algorithms, try to come up with the best set of hyperparameters for that model, and then validate onto some held out data set, and then you have your model, right? So as a data scientist, as a modeler, you're happy, and then you try to bring that to engineers, and your artifacts you might want to store it into some artifactory storage, and then it's up to engineers to collect this artifact and try to bundle that together with some inference code and deploy that to production. So that's the idea, and this works. I mean, this works. This is working, but there are quite some challenges related to this, and especially because it's slow, right? There is this silo approach. On one hand, you have the developers. On the other hand, you have the engineers. It's based on, how do you make sure that the data you're using are representative of the data you have in prod? So that's a challenge also, Then how do you make sure that that this training pipeline basically can live further and can be reused later if the data scientist is leaving? Then that will be a challenge also for you. And how do you version control your artifact, right? How you version control the data that was used to train the model. So how do you make sure that the model is reproducible? So that is also a challenge. And so we can collect a list of challenges and non-exhaustive. I mean, there are many challenges that we can add on top of that. So the pipeline orchestration, so how to bring this, how to chain these different tasks, the versioning I mentioned, reproducibility, collaboration with this silo approach, how to automate and make it seamless, the transition between development and production, how to retrain, and monitor the stuff. Of course, I didn't mention, but monitoring is how do you make sure that the baby is healthy, right? That's a very important aspect. And how can you re-trigger the training based on, for example, degraded performance? And so here I will show their level 2, the maturity level 2 of Google, and later we'll try to flesh it out with this Databricks platform. So here, if you remember, if you were here this morning, Ivan mentioned the feature store as this transition between data engineering and machine learning engineering, and that's really the transition between the data pipelines and the modelers, basically. So the feature store is really this capability which allows you to register features that you can engineer, in your team, and share them between the members of your team or between teams. And also the feature store, obviously, that's one very important aspect of it, is there to make sure that these features you're using at training time have the same logic, are exactly the same as the one that you consume during inference, right? That's really the use case, the main important use case for the feature store. So you start with a feature store, and then as previously you have this pipeline, but now we orchestrate it, we chain it, a bit like in Airflow you can chain tasks, right? So you make sure that you can chain the different tasks that builds your model, right? Training, validation, everything, and then you make sure that this pipeline you will deploy it, and so you don't deploy just the inference code, not only the inference, but also the pipeline that is needed to train the model. And the code of this thing obviously you can use the classical DevOps approach of CI and CD, so using unit tests, code quality checks and stuff to make sure that this is healthy, and then you can bring the pipeline to another environment, so separated from the development environment. And then there is the model registry aspect, because model is not just code, as Ivan and Karina said this morning. I mean, a model is of course it's made of code, but much more than that. It's based on the data that were used to train it, right? So you need to have the pointer to the data, right? You need also to track the hyperparameters that were used to train a model. Any metrics, validation metrics, you can collect them. So everything that makes your model reproducible is collected in the model registry. And using that, then you can deploy your application and have it monitored for data drift, concept drift, and things like that, right? And then with some triggers, you can re-trigger the training of your model at will, right? So that is the level 2 compared to the level 0, of maturity of these deployments of machine learning models. And now what I will try to do is to flesh this out with a specific platform, which is Databricks. And I will use the four environments. So one for development, one for staging, then pre-production and production. And same as earlier, just a little bit expanded. We have this training pipeline and inference pipeline within your development environment. It's a workspace in Databricks jargon, which you can reach from your own IDE if you need so, or you can code in the workspace itself. And you can run your experiments. Experiments are basically one model training realization, and record that into your tracking system to make sure that it is reproducible, and then use the CI to check the code quality of the code as earlier, and then you will deploy the pipeline as earlier showed within a specific environment detached from your development environment, and this can be triggered, changed using Airflow and scheduled, and this will be trained, and the model trained here will be validated, and then it will get a tag staging. That's in MLflow jargon. That's the tag. There are 4 tags: none, staging, production, and archived when models are decommissioned. So this will get the tag staging, and will be registered in the model registry, which is common to multiple platforms. And then you can this time deploy not the training pipeline but the inference pipeline in another environment, which is this pre-production environment. This is meant to for the model to be tested and made available to business, so that business can evaluate the performance of the model before pushing it to production, right? And the last thing is then to move it to the last platform, which is production, right? So that's the process flow of such a Google level 2 architecture for Databricks, for example. And what I will do now, I will deep dive into one of the challenge, which is the seamless deployment, and this is tackled by the CI/CD pipeline. So I just reproduced on the right here the same process flow just for reference, and I'll consider the Git flow. So this is a GitOps approach in the sense that every event, every deployment, every CI execution is triggered from Git. So Git is really this engine, right? So let's say you have your your repo main branch, and then you want to fork into a develop branch, which would be the branch of the team, basically, the branch where the team will come back once they want to bring any new functionality of the model. And then data scientists can go into their own branch and experiment stuff, build models, and track them into MLflow experiments, and it's very iterative, you know. So figure out what is the best model, and then once they do so, they want to bring the code back to the team branch, right, to the development branch, and they do so in a pull request, obviously, and that pull request can be the trigger for the CI. And so here, for example, is an example with these GitHub pipelines, GitHub Actions, but you can use whatever kind of other tools like, you know, Azure DevOps or GitLab or anything else. This is just as an example. So basically, you can, in the GitHub Actions, install any requirements files to make your environment in Python, then linting, and then run your unit tests and record everything into, for example, Sonar Cloud or Sonar Cube or any such capability that, you know, gives you the quality of your code, basically. How the code is good. And this is pure DevOps. This is where we stand on the shoulders of giants. And for example, there is such a tool, Sonar Cloud, but there's others which allow you to evaluate, you know, if your pull request makes sense. In this case, it's quite not the case because you have many smells, many issues, coverage is missing. There was no unit test, and so that's how DevOps engineers evaluate if you can accept the pull request or not. But there is also the machine learning aspect. And for the machine learning aspect, the reviewer of the PR would go and check these experiments which have been tracked, which contain all these parameters and metrics, anything about the model. So anything that makes the model reproducible, and can then check whether, for example, the accuracy, ROC makes sense, you know. So evaluate basically if the model makes sense. So before the code to be merged into the team. And then they do so. So basically what we did, we went through this loop, right? We can iterate so that the code gets better and better. Then we can repeat this approach over and over because I mean, machine learning is really iterative. And finally, we want to bring this code to production. So to do that, you will create a pull request. And again, Git is the engine, so it will trigger a pipeline. In this case, it will trigger the deployment of the training pipeline to another environment, here to the staging environment, where the code will be retrained. And that is when you have some pipeline for that. You define the target environment where you want to deploy the stuff, and Databricks has this nice DBX. It's a CLI which allows you to very easily deploy these jobs without entering too much into detail. You can deploy the training and validation. And here's just a JSON file that contains details about the jobs. I don't want to bother you about the details. So basically, I mean, just you can define anything about the jobs for the training, for the validation. And talking about training and validation, as we like Python in this conference, I just show pseudocode of Python for the training and for the validation. So basically, it's pseudocode, right? It's not the full code. Just I took the chunks that were interesting for us. So on the top here, we have the feature store aspect. So let's say you have registered features into the feature store. And now that's the place where you go and fetch these features, right? You fetch the features, from the feature stores. In Databricks, these are just delta tables. Delta, if you know, it's Parquet files plus the log. I don't know if you know Delta. It's a cool data storage, which allow to version control your data. Yeah, and so that is for the feature store. How you go and fetch the features, and then you have the training aspect. I mean, very classical stuff. With at the end, you can register the model to the model register to MLflow. And then on the other side, you have the validation. How you will do? You will just fetch the model which has been registered and then predict onto some test data set, you know, and then you can validate, make sure that the performance is at least as well as an expected baseline performance, and then you will say, okay, that works. Move the tag to staging, and that is that is here. And then in the MLflow UI, you will see that the tag is staging basically, and that is basically what we did was that. So we have trained, and now we have the staging tag, and then last thing in this pipeline, we want to deploy the inference code. So the inference pipeline this time to the pre-production environment, so the QA, so that business can see the model and evaluate and say, okay, we want this in production or not. And so that step is done here. Basically, you deploy your inference job and you run it. You schedule it. You can do that using the Databricks native scheduler, or you can do that using Airflow. That's also feasible. And the inference, so the code looks like that. You basically declare the feature store, and you get you get a version and address of the model, and basically you just score it. That's very easy. The fetching of features is done behind the scene here. You don't have to bother with that basically, and that's for the inference. And then the last step is then to reproduce the same. Yeah. So basically, let's say business have observed that the output of the model makes sense, and they say, okay, we want this in production. Okay. So that's the moment where we can merge the PR, and then this will trigger a last pipeline. I don't show, but that's the same. It will re-trigger. It will trigger the deployment of the inference pipeline to production, and now the tag will be production, and then you have a version for your model, and you can add any other XYZ version for your model basically. And so you can reproduce, you can go over and over, and so that's basically the machinery for the deployment using CI/CD for machine learning models. So that was in a nutshell how it can be done on such platform. It can be done on many different platforms. It can be done, Kubeflow platform, for example, or using whatever kind of platforms. What I wanted to say is that the important thing is that you need to have a process flow, like this maturity process flow from Google. I think that's the first thing, and then you can flesh this out with your own platform and your own specificity, own tools. It's not about the tool; it's more about the capability that you want to enable. Yeah, and so that's it.